Section 2.7b, slant asymptotes. Up until now, we've talked about vertical and horizontal asymptotes. Slant asymptote occurs only when the degree of the numerator is exactly 1 degree larger than that of the denominator. Remember, when the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. So when that's the case, there could be a slant asymptote if that numerator is exactly 1 degree larger than that of the denominator. So there can never be a horizontal and slant asymptote together. Okay. Also, just because there is not a horizontal asymptote does not mean there has to be a slant asymptote, because the slant asymptote only can happen when the numerator is exactly 1 degree larger than the denominator. We find a slant asymptote through division. So we're going to do everything the same way that we did in section 2.7a. We're going to list all the same information, but now we need to check and make sure that we don't have a situation in which we have a slant asymptote in our function. Factor this. This numerator factors as x minus 2 and x plus 1. We can see that none of the factors are going to cancel. Since none of the factors are going to cancel, we know right away again that there are no holes in our graph. Vertical asymptote. Take the denominator, set it equal to 0. We have a vertical asymptote at x equals 1. Horizontal asymptote. Numerator is larger than the degree of the denominator. That tells us that we have no horizontal asymptote. But since the numerator is exactly 1 degree larger, degree 2 over degree 1, that tells us that we do have a slant asymptote. So we're going to take and we are going to divide out this function. We're going to take x minus 1. We're going to divide that into x squared minus x minus 2. What times x equals x squared? That's x. Multiply. Subtract. X squared minus x squared gone. Negative x plus x gone. Bring down the negative 2. The negative 2 is our remainder. Once you get to a remainder, when you are identifying a slant asymptote, you are done. The remainder means nothing. You are looking only at how many times the factor divides evenly into the numerator. So in this case, I shouldn't say factor, however many times the denominator divides evenly into the numerator. In this case, it went in x times. So our asymptote is going to be y equals x. Intercepts. X-intercept, we set the numerator equal to 0. We get out 2, 0 and negative 1, 0. Y-intercept, plug in 0 for x. We get negative 2 over negative 1, which is 2. Start graphing all the info that we have again. Vertical asymptote at x equals 1. Slant asymptote is the line y equals x. That has a y-intercept of 0 and a slope of 1. So we have a point at 0 and our slope is 1. So here is our slant asymptote. Go ahead and dot that in. X-intercept is at 2, 0. Y-intercept at negative 1, 0. Y-intercept at 0, 2. We should not need to plot any other points. Remember, our graph is separated by our vertical asymptote. So we know to the right of the vertical asymptote, we have to approach the slant asymptote here and the vertical asymptote here. Same thing to the left of the vertical asymptote. There's what our function will look like on the left of that asymptote. Letter B, factor. Take an x out of everything up top. leaves us with x minus 1. The bottom x plus 1. Nothing cancels, so there are no holes. Vertical asymptote, set the denominator equal to 0. Horizontal asymptote, we have degree 2 over degree 1. Numerator is larger than the degree of the denominator. There is none. Once again, since it is exactly 1 degree larger, we know there is a horizontal asymptote. Or I'm sorry, a slant asymptote. Take x plus 1, divide that into x squared minus x. What times x equals x squared? X, multiply. X squared minus x. Subtract that off. We are left with, I'm sorry, this should be plus here. X squared minus x squared is gone. Negative x minus x is negative 2x. Continue the long division. What times x equals negative 2x? Negative 2, multiply. Negative 2x minus 2. Subtract that. X's are gone. 0 plus 2 gives us a remainder of 2. Remember, the remainder doesn't matter. It's how many times does the denominator go evenly into the numerator. This time, our slant asymptote is y equals x minus 2. X-intercept, set that numerator equal to 0. We have 2 of them again. 0 and 1. So 0, 0, and 1, 0. Y-intercept. Plug in 0 for x. We get 0 over 1, which is 0. Okay, begin graphing this information. Vertical asymptote at x equals negative 1. Slant asymptote, we have a y-intercept at negative 2. Slope of 1. Intercepts at 0, 0, and 1, 0. So we know to the right of that vertical asymptote that our graph has to be approaching here, crossing and back up through here, and approaching. To the left of that asymptote, we do not know. We need to make an XY chart and pick a point. Pick a point to the left. Let's put in negative 2. Negative 2 squared is 4. 4 plus 2 is 6 in the bottom over negative 1. 6 over negative 1 is negative 6. So negative 2, negative 6. To the left of that vertical asymptote, our graph has to be down here. Last one. Nothing can be factored here. Nothing's going to cancel here. So we know there are no holes. Vertical asymptote, set that denominator equal to 0. Horizontal asymptote, degree 3 over degree 2. There is none, but once again, there is going to be a slant asymptote. Take x squared, divide it into that numerator. What times x squared equals negative x cubed? Negative x. Multiply. Subtract. Cubes are gone. Bring down the x squared. What times x squared equals x squared? 1. Multiply. Subtract. Bring down the 4. That's our remainder. So this divides evenly. Negative x plus 1 times. There's our slant asymptote. X-intercept now. Find our x-intercept. We set that numerator equal to 0. Well, if I set the numerator equal to 0 here, we have negative x cubed plus x squared plus 4 equals 0. We don't have a way of factoring to solve that, so we need to go to our calculator. Let's go to our calculator here. and put that function in. Y equals negative x cubed plus x squared plus 4. Look at the graph. We can see that that graph has one x-intercept. Let's verify where that is at. Set the left bound for your 0. Set the right bound. Hit enter again. We see that it crosses at 2, so that means our x-intercept is at 2, 0. Y-intercept. Put in 0 for x, we get 4 over 0. Undefined. That means there is none. Graph what we have so far. Vertical asymptote at x equals 0. Slant asymptote y equals negative x plus 1. So we have a y-intercept at 1. Slope of negative 1 this time. X-intercept is at 2, 0. So to the right of that vertical asymptote, we know that our graph has to be in here. To the left, we're not sure. We need to go and plug in a point. Let's plug in negative 1 for x. Put in negative 1 for x. We're going to get out negative 1 cubed, which is negative 1. Apply that negative in front. That's 1. 1 plus 1 is 2. 2 plus 4 is 6. 6 over 1 is 6. So I have a point at negative 1. Up 6. So to the left of that vertical asymptote, our graph has to be up in that section there.